Breaking news tonight, quantum. AI scans have confirmed that the interstellar object known as 3I-ATLAS is far from natural. A glowing emerald-colored object from another star system is now moving through our cosmic neighborhood. But Earth's telescopes are blinded by the sun. NASA websites remain intermittently offline due to a government shutdown, creating an unprecedented observational gap. This mysterious visitor, dubbed 3I Atlas, passed near Mars at a staggering 60 kilometers per second, defying every known rule of comet physics. Only spacecraft orbiting Mars could witness its contralateral tail and flickering green shell. What is it made of, and why is it completely immune to the solar storms that normally shred comets apart? Stay tuned, because what happens next will challenge everything we know about our solar system. If you're fascinated by the mysteries of 3I Atlas, hit that like button now to let the universe know you are watching. Every click keeps the quest for the unknown alive. Comment below and tell us where you're rewatching from. I want to see which corners of Earth are sharing this cosmic moment. Humanity encountered an extraordinary paradox when 3I-ATLAS, the third confirmed interstellar object, approached the inner solar system at a time when Earth's astronomical infrastructure was in turmoil. Ground-based observatories were effectively offline, sunlight obscured instruments, and government disruptions delayed official data release. Meanwhile, Mars became humanity's only vantage point to witness this historic encounter. On October 3rd, the emerald-hued wanderer passed within 30 million kilometers of Mars, creating a rare observing opportunity. Earth, blinded by solar glare, could only watch from a distance. Mars orbital mechanics opened a unique window, providing an angular separation of more than 40 degrees for orbiters and rovers to monitor. 3I-ATLAS. During this brief period, Mars became humanity's primary astronomical observatory, able to continuously monitor a visitor from beyond the stars. From late September to early November, the elongation angle between Earth and 3I Atlas fell below 10 degrees, placing the object dangerously close to the Sun from our perspective. Observatories worldwide were forced into shutdowns, following strict safety protocols to protect instruments worth hundreds of millions of dollars. For 6 consecutive weeks, Earth's telescopes could barely access the interstellar visitor. This created an unprecedented data gap, leaving astronomers to wonder if something was hidden in the sunlit region or if it was simply a cosmic coincidence. Either way, 3I Atlas presented a scientific challenge unlike any other. Mars' orbital advantage turned the planet into a frontline observatory. Every orbital pass and surface observation from spacecraft like Perseverance, Mars Reconnaissance Orbiter, and Tianwen-1 became crucial. These assets allowed scientists to monitor changes in the object's behavior, flares, or anomalies that Earth-based observers would otherwise miss. Perseverance Rover, for instance, conducted a 9-minute sky survey on October 2nd using its Mastcam-Z camera. Each image captured a faint streak of light aligned precisely with predictions of 3I Atlas trajectory. If confirmed, this would mark the first observation of an interstellar object from the surface of another planet. The observational campaign was not limited to NASA. The European Space Agency contributed with Mars Express and Mars Trace Gas Orbiter, offering high-resolution imaging and spectroscopy. These instruments allowed detailed chemical and structural analysis from visible light to infrared and ultraviolet wavelengths. The UAE's Hope orbiter, originally designed for Martian atmospheric studies, demonstrated its unexpected versatility by tracking the comet. Its wide-field imaging made it especially useful during periods when Mars orbiters could not maintain continuous observation. Meanwhile, China's Tianwen-1 mission added imaging and near-infrared spectroscopy. Though official data releases remained minimal, the result was a layered international observational network, each asset contributing unique insights into this cosmic enigma. Ground-based observations prior to Earth's blackout revealed astonishing features of 3I Atlas. A green halo nearly 700,000 kilometers wide stretched across space, nearly twice the distance from Earth to the Moon. Its color is caused by sunlight passing through diatomic carbon and exotic gases, creating an almost artificial glow. Unlike normal comets, which exhibit long, trailing dust tails, 3I Atlas displayed a distinct antitela wedge-shaped structure pointing toward the Sun rather than away from it. Its episodic ejections and arc-shaped shell structures suggested a complex, organized mechanism, unlike anything seen in typical cometary physics. 3I Atlas speed defied expectations. Passing near Mars at 60 kilometers per second, models predict it could accelerate to 68 kilometers per second near perihelion, far faster than conventional long-period comets, which typically move at 20 to 30 kilometers per second. Even its trajectory raised eyebrows, as it traveled nearly parallel to the ecliptic, aligning almost perfectly with the main orbital plane. Statistically, this is extremely rare for interstellar objects, leading some astronomers to question whether an unknown guidance mechanism or natural energy source could be influencing its path. Based on its brightness and surrounding halo, 3I Atlas core is estimated at 5 kilometers across or larger, ranking it among the largest interstellar objects ever observed. Its mass could carry materials never before seen from beyond the solar system, making it a unique target for scientific study. At the same time, its size raises concerns. Any object of this magnitude carries enough energy to impact its environment, whether through gravitational interactions, particle emissions, or magnetic influences. Scientists continue to study the resilience of its structure against solar phenomena, including coronal mass ejections. On September 25, a coronal mass ejection from the Sun directly impacted 3I Atlas. Typical comets react violently, with structural deformations, rapid brightening, or ionized gas emissions. Remarkably, 3I Atlas showed minimal response. Its green halo remained intact, the antitail stayed sharply defined, and no sudden expansion or fragmentation was observed. This resilience puzzled plasma physicists and suggested an unusual internal composition or surface mechanism shielding it from solar activity. 3I Atlas is confirmed on a hyperbolic orbit, verifying its interstellar origin alongside 1I Oumuamua and 2I Borisov. Yet scientists debate its classification. Traditionalists cite outgassing, layered crusts, and a green halo as evidence for a cometary nature. Skeptics point to the antitail, absence of a dust tail, stable structure, and mechanical velocity as indications of something beyond natural comet behavior. This debate underscores the limits of existing theoretical frameworks and challenges astronomers to reconsider assumptions about small bodies entering our solar system. Even amid political and administrative delays, the astronomical community embraced real-time collaboration. Raw images and preliminary spectra were shared through public archives, including ESA UAE, NASA, and independent comet observation databases. During periods of data blackout due to government shutdowns, citizen scientists and independent observatories analyzed image stacks, orbital trajectories, and photometric data, maintaining a near-continuous stream of updates. As 3I Atlas moves toward perihelion, fundamental questions remain. What is its exact chemical composition? How did its unusual crust form? Why does it lack a typical dust tail? How does it resist solar plasma impacts? Ongoing missions and phased data releases promise answers over months or even years, with some datasets expected as late as 2026. Each measurement could solve current mysteries or reveal entirely new ones, reaffirming the object's role as a cosmic enigma. The case of 3I Atlas illustrates both the capabilities and limitations of modern astronomy. Even with a vast network of ground-based and space-based observatories, the combination of solar geometry, political circumstances, and observational constraints can create gaps in scientific knowledge. Mars' instrumental role highlights the importance of distributed networks and international collaboration in space science. The interstellar visitor demonstrates that the universe retains the ability to surprise humanity in ways we cannot predict. 3I Atlas is a reminder that even our most sophisticated models are fallible when faced with true cosmic anomalies. Its emerald glow, antitail, unusual speed, and resilience challenge expectations. As more data emerges, each observation will enrich our understanding of interstellar phenomena, test our models, and push the boundaries of astronomy. The full story of this mysterious object is still unfolding, promising years of discovery, debate, and wonder.